So a few months ago, I did the fire damage cluster repair and had a lot of fun with that one. And so I thought it'd be interesting to do one that is P damaged. So let's see what we got here. This is the original email he first sent me. He says, I bought an '05 Silverado with extensive mouse damage. The instrument cluster has never shown the mileage and all the gauges seem to have issues. I hooked up a scanner and was able to get the mileage. I sent it to a repair facility with a great website. They said it's junk. They say they get 2 per year that cannot be saved, and this is one of them. It does show signs of staining on the back from urine. I am reluctant to pay for shipping again, but if you are confident you can fix it, I will send it. And then I just asked for more details, like why did they say it can't be repaired? And he just said, they just said it does not respond to what usually works. He said something about the speedometer and odometer display. He recommended an aftermarket, but they are all back ordered. Do you sell rebuilt units? Yes, I do sell rebuilt units, but I usually kind of like to leave that as a last resort. I like to try to save the original cluster first. So let's see if we can save this one. Power it up. Oop. Okay. So I did see movement out of all the stepper motors. We got a bit of an issue with the mile per hour. I'm gonna reboot it again. I think I went in the wrong direction. Yeah, when it acts like that, it's usually from a ripped foil pad, ripped up trace, usually from improper stepper motor removal, just some careless force or too much heat. And anyways, it's just typical ripped up pads. But yeah, there's no displays, so that is an issue. Let's take it apart and see how bad the mouse P really is, and see if it can be saved. Okay, first glance, doesn't look too bad. To the back side, that's fairly clean too. I usually see worse corrosion from just from the moisture in the air than what I see here from any mouse P. See, they reflowed the connector. Back looks good. Front doesn't look too bad. What I do notice on the front is lots of reflowing of everything. This was kind of the technician's last resort of desperation to try to get it to work. I see lots of parts reflowed that usually don't need to be reflowed. So that's that should be fine. Again, I really don't see any corrosion. It looks pretty clean. Maybe a little bit of green up here at that transistor. Let's just let's do some troubleshooting, shall we? See if I can get my meter in view, although see if we can get a shot of everything here. Which is set to DC, so we have no displays. Both displays. These run on different power sources, so it's whatever is feeding both power sources is the issue. Now, if I check from here, I should see about 42 volts, I believe, or something in that ballpark. And there's nothing. I think this is the 12 volt side, which is turned on and off by, I believe, this transistor here. This is the switching power supply to make the high voltage to run the driver info display. So I should see 12 volts on at least one of these pins, and yeah, nothing. I believe this section is what runs. Let's just see if there's any power. I wonder if that's pulled to ground. I bet that's pulled to ground. Okay. Looks like there is an issue with power delivery getting to the switching power supply. Okay, so I just did some poking around on a good board that's also a 2005 model. And yes, there is supposed to be 12 volts with this capacitor, and there's not, which is supposed to be fed from this transistor. So you can see that here. This is what kind of turns on this power supply, and it's not getting fed. And I believe it's fed from this one here, and that's not, it doesn't have an output, although it does have 12 volts coming into this transistor, but it's not coming out because I believe this pin has to be pulled down to ground. So why is this pin floating at 12 volts, not pulled down to ground? Because that's what turns on this, which turns on this, which turns on that. So the base of this transistor is pulled down by this transistor, and this transistor should have one lead tied to ground. So I'll see if I can poke the ground on the back side of this capacitor. Okay, so that does have a ground. One of these leads goes directly to the base of this transistor, so that is good. And that leaves this last leg that gets its signal probably from the microcontroller. I suppose this is what tells this to turn on, which tells that to turn on, which tells that to turn on. So this should go to this via here. And I believe that makes a little loop to this resistor right here. It's getting kind of hard to see because the parts are getting small. So I'm going to switch over to the microscope. And I believe we're not seeing a connection from here to here, and we should be. Well, I just patched up that little tiny, all right, turn back on meter. I patched up that little tiny ripped foil going to that transistor right in there. That was I've never seen that before, where it just blew open. I suppose it could have been, I mean, I normally don't see it under normal conditions, and when there's too much current being pulled, then sure, I'll see foil blowing open, but that looked like a rip. It was really bizarre. I don't know, maybe the mouse P had something to do with it. But now we got continuity from that transistor to this resistor. So let's power it up and see if we have displays. Yeah, all right. It's only got 75 on, man. That's one hell of a butchered up cluster for having such low miles. I guess it ain't that bad. Next, let's find out why the speedometer is all janky. It should do, these are X27, so they've already been replaced to the upgraded good stepper motors. If I turn this clockwise, when I power it up, it should spin counterclockwise, and it can't. So let's just see if it's just some ripped foil from the stepper motor replacement. I have to get up in there close again. So I believe this test point's for here. Okay, so that's good. This test point is all the way over here, and that one's good. And this one, I think, goes here, or maybe to here. Wait, this one goes here. Okay, so it's this one here should go to, I believe, I don't know, one of these test points. So we just have some ripped foil going to one of the stepper motors. That's no problem. Let's run a jumper. Turns out I was wrong. This path is good. It goes to here. So all 4 of these pads are fine making their way to this end of the board. So the problem could be on the top side or possibly a via. So we either have a bad trace to the AX12 chip, or the chip itself could be damaged. That does happen too. So I have to do some more tracing to find out if we have another open or if I just need to replace that guy. So to check for continuity on the mile per hour stepper motor, I know it goes to this chip here, so I'm going to hold one lead on one pin and I'm just going to drag it across until I get a beep. Okay, so I know that connection's making it. Let's go to the next pin. Yep, that connection is good too. Let's go to the third pin. Maybe that one's got a problem. It's kind of hard to hold it and drag at the same time. I'm not getting a connection on that pin. Let's check the last pin. Okay, get a connection there. So it's this one right here is not making its way to the other side of the board, to the AX12 chip. I'm going to hold my hand on the back side again, just do one more double check. Yep, I'm not getting any continuity. Let's find out which pin it's supposed to go to. Okay, so when I check with a known good board, I should have continuity on the 8th pin over from the left. Not technically pin 8, but whatever, you get the idea. So when I do a little backtracking from that pin, I know it should go to this via here, which it does. So the top side has continuity. And I traced out the trace that it goes to on this side, and this side has continuity. It looks like it might just be a rotten via. So I'm going to dig this out a little bit and see if it can be patched up. If not, I'll just run a jumper. Well, I sure hope that microscope footage turned out good, because that was another bizarre break in the trace right after the test point on the back of the board. Just weird. it's not like burnt, like there was an excessive amount of current that came through. It was just a rip in the foil. Again, weird. The second time on the same board. I guess that mouse P does weird things, but now I have continuity, right? Yeah, there we go. I got continuity all the way to stepper motor to that driver chip. So I should get a nice smooth sweep out of this mile-per-hour stepper motor now. That should be the last of our problems. Let's find out. What? What the fuck? It's still screwed up? What the hell's going on here? Huh. I guess I better double check myself to make sure I actually have continuity all the way to the chip. So I'm going to hold one test lead there, and then here I should have continuity. My meter's not giving me any beeps. How can there be a second failed trace on the same line? So I know the backside's good. I'm all the way to there. So crying out loud, there must be a bad via on the top side of that same trace. Right? Okay, right here. Man, this is just bizarre. All right, I guess I gotta dig the via out from the top side. Well, that via just kind of fell apart on me as soon as I started scraping. So it is time to just get it over with and run a jumper. That's where the magnet wire, electromagnet wire, comes in handy. It's enamel coated, so you can run it across the circuit board and not worry about it shorting things out. And yep, we're going to have to make a bit of a run here to complete this circuit. I just have to melt off the coating to get started. Never mind that little blob of solder. Come on. Alright, so we know we gotta go there, I gotta go that way. So I need to go over here. Okay, has to be about so long. And we're just gonna sneak through here. And I'll be careful that the back plastic doesn't rub up against and pinch. Yeah, sometimes these back plastics will have the pegs that stick through, but this one doesn't have the pegs that come through the hole, so I don't have to worry about it rubbing and becoming a problem. So I'll just run that through there, and we know we got to go to this 8th pin over here. Actually, the other thing I got to watch out for is that white plastic reflector. Let's see here, that doesn't touch. Okay, so I'm just making sure that the wire's not going to get pinched. So I actually have to clear. I got to stay tight to here and clear this. I don't want to go from the white to the black because there's the plastic that sits over this. So I just want to make sure I clear that. So I should need right about there. Looks good. Let's get you closer. Get a little Lewis Rossman ointment on there. And hopefully my Sharpie doesn't, hopefully my red Sharpie doesn't do something weird when I go to melt it. Just going to tin up that pin. All right. Okay. A little alcohol bath. And I'll scooch this wire out of the way so it's not pinched by the light guide that lays over the top. How's that look? You're not going to focus? There you go. Okay, let's check it. Better work this time. Okay. Please go counterclockwise. Okay. Better. Do that again. Now I gotta let the board reset. Okay. I think we're back in business. All right, I'm gonna freshen up this guy's light bulbs, and everything else has already been reflowed by the previous technician, and the step motors are already X27. I'll make sure they're not damaged, but I didn't feel any stripped gears, so I think it's time to reassemble. I know some of you might be thinking, well, what if this cluster fails again? What if another trace does this odd opening, ripping, tearing, whatever the hell happened in here? If that were to happen again, I would give this customer full credit for what he paid for the rebuild service, and I would set him up with a replacement. But as of now, the corrosion that's on there is actually really light. It's nothing compared to your average MacBook. I don't see a future problem now that the mice are cleaned out and there shouldn't be any more fresh pee making its way to the cluster. But as of now, everything works. We got tachometer, mile per hour are working normal. Oil, volt, fuel, and temp. We'll have to do a reboot to get the full on the gas gauge there. All right, now I got turned up all the way. All right. Yeah. Point made. It works. Crank the voltage up. There we go. All the gauges are working. Blinkers are working. Indicators are working. Both displays are working. This cluster is fixed. So thanks for coming along on this little oddball journey. And we'll see you next time.